Bismillahirrahmanirrahim, and welcome to another video lecture from CSRDU. Those of you who don't know, I am Mohammad Nauman, the team lead at CSRDU, and currently I am a lecturer at FAST National University of Computer and Emerging Sciences, Peshawar campus. We're putting together a lecture series using this screencast system on document preparation using LaTeX 2E. What we're planning on doing is, first of all, to introduce you to LaTeX, then talk about why we need to use it, or in other words, what's wrong with MS Word. We're going to talk a little bit about terminology, then we'll get started with installing the software, setting up the preferences, and then we'll move on to the document structure in LaTeX, how we set the document class, sections, subsections, formatting, all of that. We'll also cover the details of how you can import figures and tables in your documents, how to use packages, or what's with this undefined control sequence in LaTeX. That's one of the major problems that newbies faced when they move from something like Microsoft Office or OpenOffice, LibreOffice to something like LaTeX. Then we'll talk about how you can typeset mathematics or equations in general in your documents, and we'll talk about how you can create bibliographies, references, and how not to have headaches while working with them. We'll cover them in a little bit of detail. We'll also cover some of the advanced topics such as setting up algorithms, float environments in your documents, and how you can format codes, programs, policies, different types of outputs from your implementations into your documents. Finally, we'll also talk very briefly about some of the in fact, of the must-see documents that you need to see if you want to learn LaTeX. So that's the plan. First of all, let's start with the introduction to LaTeX. Very briefly, it's based on the TeX typesetting system, which was created by Donald Knuth, or Knuth, I don't know how to pronounce that. It's basically kind of a programming language that lets you typeset your documents, and then it has a compiler that produces the high quality output in different formats. The word is pronounced LaTeX. It's the sound of high in Latin or he in Arabic. If you don't know how to pronounce that, you can call it LaTeX. Some people call it LaTeX, but that would be really wrong because it's not latex, the rubber. It's at best LaTeX. Anyway, it takes in the LaTeX source and generates a number of outputs, any type of output from DVI, HTML, RTF, PDF, PostScript. We're going to be working with PDF because that's the de facto standard nowadays, but you can create all of the other formats as well. The output is concerned with placing different kinds of boxes around the page. The page is going to be the major entity in your document, and there are going to be boxes placed around all of the real estate of the page. For example, each letter is going to be a box, and those letters are going to be combined together, and another box will be created out of that, which is going to be the word, and those words are going to be placed together to create paragraphs, and paragraphs are going to be placed together in different combinations to create the whole page. So that's the general idea. You need to keep that in mind because it's going to be very helpful when you actually do the final production. Boxes are combined to form other boxes, and they are placed using fixed or elastic widths and distances. So elastic is very important, that's the default, and it helps you figure out what your document is going to look like, where the different boxes are going to go. More about why we don't want to use MS Word. The major problem with MS Word is the lack of control. You might think that it's easier to control Word, but when you are creating complex documents such as a research paper, which is, let's say, 2-column format, and you have some figures floating around, and you have some policies, and you have some algorithms, it's very difficult to actually manage how the different content flows together, and it becomes very difficult to control it. It's a big mess in general. You have to focus on content and presentation at the same time. You have to think about what you're trying to say as well as how it's going to appear, and that's not a good idea in general. That's why you have HTML separated from CSS and all of those things. In general, you want to keep content separate from presentation, so that when you're thinking about content, you can think about what you want to say instead of having to worry about how it's going to look like, what it's going to look like in the final document. So that's something that's wrong with MS Word. You have to think about both of those things at the same time. It requires too much effort to format for specific conferences or journals, and once you have a document in a specific conference format, if you want to shift to another conference format or to a journal format, it becomes extremely difficult and requires too much effort. It's difficult to manage versions. Of course, you have tracking and all kinds of different tools available with Microsoft, but in general, it's much more difficult to manage versions with MS Word. Whereas with LaTeX, since the source code is text-based, you can use all of the different version control systems like Subversion, Git, CVS, all of those to not only manage revisions yourself, but also create collaborations with your co-authors. It's also very difficult to manage references in MS Word. Even if you have EndNote, it becomes very difficult to keep track of your references and create different types of bibliography formats with that. It becomes a little easier with EndNote, but as you'll see in LaTeX, it's much easier and it's much more powerful. What's wrong with LaTeX? There has to be something wrong. The very first thing is you need to learn how to use it. It's not point and click, it's not WYSIWYG, so you have to know what the commands are, but as you'll see, that is very easy and very easily learned. So that's not that big of a deal. It's not completely intuitive for some people. Once you get to know it, it's much more easier, and you would probably come to like it so much that you would find it much more counterintuitive to use MS Word. I've found myself thinking that it would have been much easier had I written my letters in LaTeX. So it depends on how much you use LaTeX, but if you continue using it, it becomes much easier for you, especially in the long run. So that was the basic introduction of why I want to learn LaTeX. And one of the things that I haven't really focused here is the quality of output produced. MS Word was not meant for high quality output. It's a word processing software. It's meant for writing letters and small documents. It's not a typesetting system, so it does not produce high quality output, whereas LaTeX was meant to be targeting print media. So the documents that you produce here, the research papers especially, they are going to look extremely beautiful when you produce the final output and you try to take a printout or send it to a journal. The final output is extremely beautiful. So coming back to the technical stuff, in terminology, we have some very basic stuff. The document is the output. That's fairly obvious. The document class is the main type defining the document. For example, a document class can be an article if you're writing an article. It can be a book if your document is going to be a book. So you can have different types of document classes, and different people define their own document classes. For example, the IEEE has defined their own document class for their transaction journals. ACM has its own special interest group class file, which you can use to typeset ACM ACM proceeding format documents. So those are the things that you basically use to define what your document is going to be. A package is basically a file encapsulating commands for a specific purpose. A common example is the graphics package, which basically helps you embed different types of graphics in your document. Or you can have a package for the URLs, which lets you typeset different types of World Wide Web URLs in your documents, and all of those different things that we'll see when we get to the practicals. .style files are the style files which are basically combined to create packages, and they are what define the new commands in LaTeX. We'll see examples of that in a minute. We have the CLS documents, which are the document class files. So all the document class files are represented with the CLS extensions. You have in the several common implementations of LaTeX, you have a file name database. LaTeX is a very low level mechanism, so it basically maintains a list of all the files that it knows about, the packages, style files, all of those things, and sometimes you need to update them. It's not very common, so you don't have to worry about it, but that's something you should know, that there is a file hierarchy in LaTeX that it maintains, and sometimes you have to update it. We'll come to that if we find a problem with that. Some of the must-see documents: a not-so-short introduction to LaTeX. It's, as the name implies, it's a not-so-short introduction, but it's extremely helpful. If you can go through that document, you don't need my videos. It's very helpful, and it's very interesting read. So you can go through that, but it's very long and it takes quite a lot of time, and you have to extract whatever is important for you. What we're going to be covering in this video, in these videos, set of videos, is going to be the core of what you need to do to write research papers. The other document is the LaTeX comprehensive symbol list. When you are trying to create different types of documents, sometimes you need to create new symbols. Again, we'll see examples of that, but if you're trying to find new and interesting symbols, you might want to look at this document. So both of those, if you search for these strings on the internet, you can find them quite easily, and I urge you to go and find these documents, download them, go through them. So getting to the practical part, to work with LaTeX, you need first of all an editor, which is going to be your IDE, Integrated Development Environment, in which you are going to create the document. It can be Technic Center for Windows, Kyle on Linux, WinEDT, LED are platform independent. You can run them on Windows or Linux. I prefer Technic Center on Windows and Kyle on Linux. Kyle is extremely powerful, but it's not available on Windows, so we use Technic Center in Windows. You are also going to need a compiler, which is basically going to take whatever you write, the document that you write in the editor, and compile it. On Windows we have MikTeX, extremely powerful LaTeX editor. On Linux we have TechLive, TechTeX. TechTeX was the old one, now you have TechLive. So those are the things. In Windows we are going to use MikTeX, so we're going to start with that in our demo. So let's get started with the installation first of all. That's the first thing we're going to do, because we need to have the software to get started. So what you're going to do is, first of all, get these two softwares. The MikTeX setup you can get from miktech.org. The current version is MikTeX 2.9. You can go over here and download the basic MikTeX 2.9 installer. You can click on download and you will get it. You are also going to need the Technic Center, which you can get from techniccenter.org. You click on download and just scroll down to Technic Center 1 RC1 installer. You can download both of these. We've downloaded both of these here. If you're on the if you have access to the fast lecture server, you can get these from my folder on the lecture server. If not, you can just download them off the internet. And basically what you want to do is, first of all, start the MikTeX setup. That's because the Technic Center setup is going to require a compiler. It's going to require a compiler when you want to set it up. The setup is fairly easy. You accept the agreement, click on next. You just keep on clicking next, and at the end you click on start, and it will start the installation. So once the setup is done, what you want to do is start the Technic Center installation. This is also very easy. What you want to do is click on next, accept the agreement, and basically install it wherever, it doesn't matter. Once the setup is done, click on finish, and you want to start the newly installed software. On the first install, you are going to have to do a little bit of configuration for this Technic Center. So you get a tip, you can either read the tip or just click on close. This is the configuration that you have to do. You need to tell it where the compiler is, and our compiler is available in C colon program files, MikTeX 2.9, that's the default location, and within that you need to find the MikTeX folder and give it the bin folder, because that is where the text distribution binaries or executables are present. So you give it the C colon program files, MikTeX 2.9, MikTeX/bin directory, and click on next. It also needs a PostScript viewer, so if you don't have a PostScript viewer, it's fine, but if you have the Acrobat Professional installed, it will already pick it up. Okay. You also have to show it a PDF viewer, so you can just download the Acrobat reader to act as your PDF viewer, and if it's installed, it's going to pick it up automatically. If not, you can click on browse and browse to whatever the location is and give it the executable that can show you the PDFs. Click on next and just take a look at these different profiles and finish. You don't have to do anything with them as such. So after that, we are going to do just a little bit of configuration for this MikTeX editor. What we want is to enable, first of all, the spelling checking. So you go to tools, go to options, and in the spellings tab you want to enable check spelling while typing, and click on OK. It's going to basically give you a warning that the personal dictionary is not available, so you can click on OK and it will create that personal dictionary for you. What that's going to do is allow you to have the word style spelling checking, real-time spelling checking, in which if you make a spelling mistake, it underlines it in a squiggly red line. So that's very helpful. Another thing that I'm going to do to make the screencast easier is change the text format for the editor from 10-point font to a 12-point font, so that it's easier for you to read. Okay? But you don't have to do that. So that's it for now. Next time we are going to create our first LaTeX document, inshallah. See you then.